let me start with introducing myself. My name is Verena Peach. I am the academic program manager for Dragonfly, and I will be hosting this series called Dragonfly Science Talk. It's a series of webinars where I invite speakers from different fields of study and research, and those speakers are people who are well familiar with Dragonfly and using it in their research for producing some analyses, visualizations, or also working, for example, in museums collections and digitize their samples and objects with the software, making use of our, and this is now an advertisement, of the nice rendering capabilities that we have. And yeah, so as said, our invited speaker of today is Dr. Andrew Nelson. I will hand over to him a bit later because I would like to first start with a short view or a short glance into Dragonfly Social, our community platform. Most of you should have familiarized yourselves already with this community platform when registering for this event, for example. You can find them, especially or to be more precise, you can find our upcoming events in the space that has holding the same name, upcoming events. Today you are joining the Dragonfly Science Talk on the Mummies as Microcosms Workflow. And also you can find in the section of past recordings, all past webinars as a recording here. It has, in this view that I am showing here, this small lock, because when I took the screenshot, I was logged out. You would have to log in first. If you are not registered yet, register, get an account, log in to then access all those contents that are only visible, marked with a lock, when you are a registered user. So it's well worth it to register. What I would like to highlight here, it's somehow correlated to the Science Talk series. We have many researchers out there. I am sure few of you attending right now are working with Dragonfly in your research as well. So go, if you want to, and I highly recommend it, go to the space called publication submission. We have a fixed posting here that describes the process of submitting your research to share it with the community. And out of all those shared publications, we would then choose ones that are getting highlighted on our website and also these contents are shared in our newsletter, on social media, to highlight you, promote you as an author, as a scientist, promote your research. And also for us, it's very beneficial to see what all the users in academia out there using a free of charge 3D license for the non-commercial purposes, what you are doing and what you are producing with the software. And you find it, as said, the publication spotlights on the resources tab on our website when you go to publication spotlight, and then you end up here. This is a very recent publication that we highlighted in the spotlight. It just was published a week ago. Yeah, feel free to grab your phone if it is right next to you in the moment. Here's a QR code that would lead you exactly to this page that I am showing here. And as said, if you are not registered yet already, grab your phone, take the chance to scan the QR code and register right away, or at latest after the webinar. You should definitely listen now to Dr. Andrew Nelson, who is presenting the Mummies as Microcosms Workflow, an imaging journey through time. And I leave it up to you, Andrew, to introduce yourself a little further, and yeah, have fun listening to the talk.
Great. Thank you very much, Verena. So I'll bring my screen up. Just make sure everybody see my screen there. Okay. So my name is Andrew Nelson. I'm at the Department of Anthropology at the University of Western Ontario in London, Ontario in Canada. And when Verena first asked me to make a contribution to the series on my workflow with Dragonfly, my first thought was, oops, there we go. Oh, I just start off that this presentation will contain images of human remains, and so if anybody is uncomfortable with that, feel free to either duck out or to block out those images. Anyway, I thought she was referring to work that I do with. I have a micro CT scanner, Nikon micro CT scanner, I am an archaeologist. I deal with objects of cultural heritage significant. And I was trying to envision a workflow of the sorts of things that I scan with the scanner, which range from medieval prayer beads to medieval reliquaries. This particular reliquary is gold and silver. It's worth 10 million pounds. To clay tablets from to ceramics from Peru, to this is a mummified Egyptian fetus. And I was kind of stalled because workflow, everything is different. So the workflow is actually extremely, it is different every time. So I thought, that's probably not going to work. So what I am going to do today is I'm going to put on my bioarchaeologist hat. And a bioarchaeologist is somebody who studies human remains from archaeological sites, so moving away from artifacts and things for the most part. I am not Indiana Jones, although I have been held at gunpoint and taken hostage for a while, but that was not Indiana Jones type stuff. And I'm taking you to Peru, and specifically to the Central Coast of Peru, to look at mummy bundles, and I'll explain exactly what those are in a sec, that date from about 600 AD to about 1532, which is the time of the Spanish conquest of Peru. And these bundles, known in Spanish as fardos, contain an individual who's generally in a seated flex position with associated artifacts and things, and then lots and lots of textiles wrapped up to form this bundle, which we refer to as the fardo. And so the title of the talk, the title of my project, Mummies as Microcosms, is this fardo is a microcosm of the biological and cultural identity of the individual within, and how they lived, but also how they were treated in death. And so fardos have traditionally been studied by autopsying them, by unwrapping them. So there's an intact fardo there. Here's it, the individual partially unwrapped. You can see, peanuts and silver bracelets and various other things there that you can see his sling around his head. And then there's the individual at the end. And so this is incredibly informative, but it's also very destructive. And what it does is it atomizes the microcosm. So you take it apart, you can see everything, you can identify everything, but in museum collections, the metals end up in the metals collection, textiles end up in textiles, bones go to the physical anthropology and all the other artifacts. And so you blow up the microcosm, and it's extremely difficult to ever bring that back. And further to the point, the Peruvian Ministry of Culture in 2020 issued this new guide for working with archaeological objects. And according to this guide, projects should avoid separating sets of materials of different nature that are physically united, such as funerary bundles and other sorts of things. And so really the only time that you should be unwrapping or autopsying these things is when they're already falling apart, and it's part of the conservation effort. So the key project of my goal is to use non-destructive imaging as a means of maximizing the information that we can collect from these fardos, and to then study the microcosm as an intact thing. And we use Dragonfly as our visualization component of the workflow. So that's really what we're here to talk about. And so How do we know what's inside a fardo? The answer is we actually don't at the beginning, which is actually, that's a lot of the way archaeology works. When we start excavating a site, we don't know what's going to be under the ground. And so what we do in terms of the fardos is we use radiographic imaging. In this case, we're using an X-ray, but we also use CT, and that's where Dragonfly as a visualization tool comes in. And so because we don't actually know what's inside these bundles, it's difficult to come up with specific research questions at the beginning of the project. And so we tend to then come up with fairly general research goals of looking at change across time and across space and things like that. And so this is the first sentence of my grant proposal that was fortunately successful. And the goal of the project is to examine biological and cultural characteristics of the occupants of Central Coast of Peru to address research questions including patterns of pilgrimage, changes in mortuary practices, and patterns of health over time. Okay, and then you'll see how we start to zoom in on specific research problems as we go. And so the workflow is really we go to museums that have collections of these fardos that have been excavated from individual sites over the years. And they're generally, a site will produce many individual fardos. It's generally the case that only a selection of those is actually available for us to use. So the site that we're going to be working on this year, a site called Puruchuco, half of the fardos are in the storage area that we are going to be working at, and half of them are in another museum. And so, and turns out that they're very difficult to access in the other museum. So there's a selection of happening there in terms of what fardos are available. So we start by photographing them, measuring them, describing them, what we can see on the outside. And then a selection of those we X-ray, and that's really depending on their state of preservation and whether, you know, moving them, they're sort of solid enough to move around. And you can see the sort of the field setup there of the X-ray machine. Actually, it's just an X-ray head, and the button, and it's hanging from a beam in the storage shed where we're working, and the digital X-ray panel is underneath it. And of those set that we X-ray, a selection of those is CT scans. So you see in the bottom right-hand corner, there's a clinical CT scanner in Lima, and it's only very recently that those have become available, and that we've established the relationship such that we can start CTing these mummy bundles. So the whole thing is a process of selection. And so what are the criteria for the selection? Well, key is the state of preservation of the bundle. And now, particularly once we get the X-rays, we can start to zoom in on specific research questions. And so I've got students working on mortuary treatment of non-adults. They're treated a little bit differently from adults. How does status affect how one is treated in death, and how one's life unfolds, you know, patterns of health and trauma and things like that. Association of artifacts and gender. And so these are a little bit more specific research questions that we can address. And a lot of this really hinges on that initial analysis of the X-rays and moving on to the CT scans. And so we're looking for, are there interesting artifacts inside? Is the individual intact inside the bundle? And is there anything unusual or surprising that would warrant the CT scan? Because ultimately CT scans cost money. So that the limiting factor is really the cost of the CT scans, and also the transportation of the bundles from the museum to the scanner. And that's where their state of preservation becomes really important. So here's the first step. We're actually at an archaeological site. This is a site of Pachacamac, just south of Lima, and we're examining that is a child mummy bundle. So the first thing since they're in collections, they're wrapped with this white acid-free paper just to sort of protect them. So we open up the acid-free paper and we look at the bundle. So there's the student beside me. She's taking notes. We've got the tape measure down to measure it, and we make some observations of the textiles and that sort of thing. And then we do the X-ray. So in order to do the X-ray, our X-ray panels have changed in size over the years. Back in 2019, it was only a 20 by 30 centimeter panel. And so we had to take a lot of x-rays of the individual fardos to get coverage of the complete one. And then those all get stitched together in Photoshop to produce the final sort of composite mosaic image. And so here we are. So again, we're hanging the X-ray machine, so we can take lateral images and we can take superior, inferior images. But one of the things, particularly after the 2019 series season, we found was that there are a lot of registration errors as we go to do the stitching. And so the take-home message was I was being stupid. I was keeping the X-ray tube still and the digital panel still, and I was moving the bundle around on the panel. You're actually supposed to keep the panel still and the X-ray head and move the bundle to make that leads to fewer registration errors. And also we had a 11 by 17 inch receptor in 2022, and then 2023 we actually had a 45 centimeter by 45 centimeter panel, and that we could then do, instead of 24 individual images, we could do 6, which made a huge difference. And then here we are at the CT scanner, and so in the different years, the settings are slightly different. A lot depends on the particular clinic and the particular technician, how flexible they are in terms of me saying I want to use this particular setting and this particular setting. And so what each year the settings of the CT are slightly different, and that becomes relevant later on when we talk about working with the CTs in Dragonfly. But one of the goals of the project is to come up with a rigid set of CT settings that we just use year after year after year. So since 2018, which I first went down and was working in that year with actual X-ray film, and then we've been using digital X-rays and then CT scans. Since that time, we've got 217 data sets, which is both X-rays and CT scans. So a lot of individuals we've got both on, but that gives us quite a large sample, and we've been able to maximize the use of that for student theses and for publications and things like that. So we go to the field, we do the X-raying, we do the CT scanning, and while Indiana Jones would take the golden idol back to the museum back in his university, we take back the gold. We take back is the digital data that then we can use Dragonfly to process. And so here's the setup in my lab. I've got this little mini network that has kind of grown in strange and unusual ways over the years, but it kind of works. My control unit is called the Tomb, and I run two software packages that are relevant to the discussion today. I first started working with the now Dragonfly folks back in 2013 using their ORS Visuals SI scientific visualization software at that point, and then as Dragonfly came on, started using that. But I still find ORS Visual quite useful for some things. But the Tomb is sort of the node of my network. Anubis, which is named after Egyptian mummies, is where all the data is stored. And currently I've got 322 gigabytes of data and 245 mummy data sets from Egypt and Peru stored there. But I also have more than 60 terabytes of micro CT data sets that I also use Dragonfly and ORS to visualize. I've got 2 computers that just feed or just draw from Anubis to do processing. So I've got one that's got ORS Visual and Dragonfly 3D World. Another one called ISIS, which is my newest computer, just has Dragonfly 3D World, and so most of the students use those computers to access the data. And then I have Anubis Workstation, which is a thin client visualization package that allows people to actually access some of the data remotely through a thin client model. And there's the image of the Maidstone mummy that Verena had at the beginning, there. And just to, as a little aside, Impact, which it's this radiological database that I have constructed of Egyptian mummies, and it lives then on Anubis WS, and people can access that remotely and use ORS web to access that data. And just for the interest of, I'm sure most of you probably don't see this screen. This is the PAC screen, which is the Picture Archive Communication System, which is a leftover from ORS visual. This is a really a medical sort of database of handling the DICOM data that goes with the CT scans, but I find it quite useful. So before we start the project, again, it's difficult to really be sure of research questions when we begin, but we've got these general ideas of looking at health, looking at mortuary rituals, and looking at change over time and across space. And so then we can come down with specific research questions and develop a specific workflow once we've got the CT scans back in the lab. So the first thing we want to do is just visualize the CT data. And so here's one of these photos, the CT scan brought up in Dragonfly. And the key, I've got circled there the 3D presets, and then the windowing and leveling area. Those are highly variable for our data sets, and so we spend a lot of time playing around with those settings, and it's been really interesting to watch Dragonfly evolve over the years, and the increase in the sophistication of the controls that we have in these areas has been a real boon in terms of our being able to visualize the data sets. And just to give you an idea, so that's the 3D view of window and level, so that you can see the textiles and everything on the outside of the bundle. This will give you an idea of what we actually start to see inside it as we start to window and level away the textiles. And so what you're seeing on the left there is a cloud of cotton seeds. So they're actually packing these bundles with raw cotton that's coming off of the cotton plants, and so it still has the seeds in it. And that could really be a nightmare in terms of visualization, trying to see through the cloud. And then on the right, you can see the individual. They're more or less in a seated flexed position, but you'll see that the bones are actually a little bit out of position, and I'll talk about that later on as being taphonomic change, which is change that happens with decomposition of the bundle and the individual. And so the first thing that we're really interested in doing is determining what we call the osteobiography, and then that gives us our general workflow, so that we got into funerary taphonomy, which I will talk about. We look at cranial modification, which I'll describe. We pull all the osteobiographies together for population level questions. We look at artifacts contained within the bundle, and we look at textiles that are wrapping the bundle. And we actually do more than this, but I thought that in terms of describing the workflow and keeping a reasonably tight presentation here, that I would concentrate on this aspect of our workflow. So the osteobiography is telling the story of the person's life through their bones, or in the case of a mummy, through any associated soft tissue. And so that's things like, I use the shape tools in Dragonfly in particular, because I can sort of manipulate them around things. I find that quite convenient to crop down. In this case, I'm cropping down to the skull of an individual here, and I'm in terms of determining the sex of the individual, I'm looking at the brow ridge, I'm looking at the size of the mastoid process, and I'm looking at the muscle attachments on the occipital bone. And in this particular case, these are all pointing to this individual being a male. And because a female would have a much less pronounced muscle markings, smaller mastoids, and smaller brow ridges. We also look at the pelvis. The pelvis is a really important thing that's different between males and females, because females have to be able to pass babies through their pelvis, whereas males don't. And so what you're looking at there is the subpubic angle. So that's where the two halves of the pelvis come together, and it's a very narrow angle there. That's indicative of it being this individual being a male, and then rotating the pelvis around a little bit. That this greater sciatic notch is also, it's quite narrow, and again indicative of this individual being a male. Looking in at the teeth, we can be sure that this is an adult. We can see the third molars are in, but we can also then start to assess something about the health of the individual. He's got teeth that are falling out. There's wasting of the roots. There's periodontal disease and various things like that. So that's all indicating, again, part of this microcosm, part of the osteobiography. And here I tried to segment this out a little bit more clearly. It didn't really work very well, but you can see that circled, that thing that's got a little tinge of green on it there is actually a piece of silver that was placed through the orbit, and it penetrates right into the cranial cavity. And that's indicative of an extended mortuary ritual where the individual is partially decomposed when they actually end up being wrapped up and buried. And I'll talk more about that in a second. So here's a much abbreviated we calculate stature. We look for trauma. We look for other evidence of pathological conditions. So, but a much abbreviated version of an osteobiography then is, this is a middle-aged adult male, poor dental health. There's no obvious evidence of trauma, and they experienced an extended mortuary ritual before they were actually buried. Part of that osteobiography, traditionally, if we're working with skeletons, if we want to estimate stature from a skeleton, we would take an individual bone, we would stick it on an osteometric board, and then we would stick it into a prediction equation and calculate the stature of that individual, the stature that individual would have had during life. But of course, we can't do that on a CT scan. And so we have to modify these techniques that we have been developed on dry bones to work in the 3D world of the CT scans. And so and if you're doing individual slices, it's actually very difficult to be sure that you're getting the maximum end of the proximal and distal parts of the bone to get the homologous measurement that you would have got on the osteometric board. So in this particular case, we use the slab view feature in Dragonfly, and so we open up a slab of the CT images, such as much like an X-ray, but we're seeing the total thickness of the bone, and so that allows us to create a measurement with, this is just the simple linear measurement tool that gives us a measurement that we can then put into the stature equation to predict a stature for the individual that is then going to be homologous to what we would have done on an osteometric board. And I've been working with students over the years, and I have a student right now who's specifically doing her MA thesis doing exactly this sort of thing. So the funerary taphonomy, I've mentioned a couple times. Taphonomy is the changes that human remains undergo from the time of death to their eventual discovery. And so we want to understand that whole sort of sequence of events so that we can better understand what we're looking at now to understand what was there originally. And so what we do, the first step in understanding this is either to look at the X-ray or to do a slab view of the entire bundle, and then to do a drawing. And people often say, well, you've got a picture, why do you need to do a drawing? And the answer is that a drawing forces you to interpret what you're seeing on the slab view or on the X-ray. It's very easy to look, oh yeah, I got a femur and a tibia and stuff like that. But if you actually go through the process of drawing the individual bones out, then you gain a much better understanding of the orientation of bones. And one of the interesting questions for us is the skeleton complete? right? Do you have all the necessary bones to represent an individual, and are they articulated with each other? And so that again is indicative. If they're not articulated, then that's indicative of taphonomic change. And so this is work that was done for one of the PhD projects as part of the overall project, and what was being documented here was that different sites had different patterns of taphonomic change, which indicated they were doing slightly different things for their mortuary rituals. And the skeletons inside the bundles were then either very complete and very well articulated, or very incomplete and very poorly articulated at the other end. And so seeing how the different sites sort of sort out that way for us is quite interesting, because it turns out that they weren't, when the individual died, they were not burying them right away. They were keeping them out for reasons that we're not entirely sure of, but the skeleton or the individual was becoming partially decomposed before they finally wrapped them and buried them. So we could observe that pattern looking at the completeness and articulation, but we're really interested to know how long that they might have been exposed. And so to do that, we went to look at bugs, and we recruited Pauline Kirgis, who was was a PhD student at the University of Bordeaux, who's an archaeoentomologist. So she studies insects and bugs and things from archaeological contexts. And so what she was actually doing was, on the left, you can see she's actually examining the mummy bundles themselves and trying to see what insect remains are inside the bundles. But with dragonfly, what she was trying to do was trying to identify insect remains actually on the CT scans, which turns out to be very, very difficult because they're very small, and the resolution on clinical CT scans is just right on the margins of what you can actually see. But she was doing a lot of playing around with the lookup tables in dragonfly, and she liked this kind of lurid blue-green one, but you can see in the bottom right-hand corner, she's actually able to identify the pupae of flies that she then is able to identify, and know, with her knowledge of the life cycle of flies, she's able to say, okay, this individual was exposed for anywhere between a few days and a few weeks after death. And the Spanish Chronicles, which are these documents that soldiers or priests who, as part of the Spanish conquest, wrote about the societies that they encountered there, a lot of them do report that there is a 5 to 10 day delay between death and burial. And so the Pauline's findings support that, and in fact, there's some of the individuals were being displayed for even longer than that. And so this illustrates that the mortuary ritual that was being practiced on the Central Coast at this time was really very complex. It wasn't just a matter of somebody dying, getting wrapped up, and being put into the ground. There was a lot more going on. One of the things that's really interesting about a lot of skeletal collections in Peru is that many of the Peruvian cultures practice what we call cranial modification, and that involves when a baby is born, the skull is still very plastic. And in the case of these two skulls here, these are called what we call frontal occipitally modified skulls. So they actually would put boards on the frontal bone and the occipital bone, and then bands in between, and that would restrict the growth and length of the skull, and that the skull would accommodate by growing sideways. And so you get these very short but very broad skulls. And there are a lot of different variants of that. This is actually this is called an annularly modified skull, and they actually wrap the skull, and so it elongates out in length. And that's a very characteristic form that's often found in the highlands. And if you see any reports in the news about aliens in Peru, that's what you're looking at, is one of these modified individuals. So to study these things, we use the deep learning capabilities of Dragonfly to segment the skulls out from the scans. We then create meshes that get ported to a program called Stradivan Checkpoint, and we do an analysis called geometric morphometrics, and this is actually underway right now with one of my students. So you can see the left image with the sort of purple background that's the mesh model that she's created using the deep learning segmentation. And on the right, it's kind of hard to see. You can see the little X's are the landmarks that she's putting in that allow this complex three-dimensional shape to be described using this procedure called geometric morphometrics. And this is from a different study. We don't have these results yet for Sorcha's work, but a different study has you put the results of the geometric morphometric into a principal components analysis, and you can separate out the annular modified guys are up in the top right, and the tabular, which is the frontal occipitally modified, are down in the bottom left. And as it turns out, well, her results are very preliminary. Other results that have done some looking at the cranial modification. It looks like the cranial modification is quite uniform in this area, and the general interpretation of that is that this is it's an ethnic marker. It's a permanent ethnic marker that says, you are my people, and so it suggests that it was not a very ethnically diverse population, which is actually quite interesting because one of the sites that we've been working on, one there mentioned Pachacamac, was thought to have been a pilgrimage center. So we were expecting that there would be a lot of diversity, but it doesn't look like it. Patterns of violence. There's a lot of sort of quotidian violence of people stubbing their toes and breaking an arm and things like that. But there's also some rather more severe violence that we're seeing within these bundles. This is an individual who has had a very violent blow to the forehead, and in fact we found this club. It actually sort of fell out of one of the other bundles. You can see it's a wooden club. It's about this long, and it's the perfect diameter to have done this blow. And so this individual was clearly sacrificed or murdered or something like that. And I'll show you a little bit more about that bundle in a minute. And perhaps even more extreme is this is a sort of a 6 to 8 year old child, and they've got 5 of these penetrating blows to the posterior part of the skull, and then they've got this very major fracture to the face. And the basal view, you can see that's even led to cracks going right across the base of the skull. And the reconstruction of what happened there, this is an illustration from one of the Spanish chronicles, and the guy's got a mace-headed, a star-headed mace club, and so that's the ideal thing to make those blows to the rear of the skull. As near as we can figure, the blow to the face was probably a large flat rock that probably weighed somewhere in the neighborhood of 20 kilos that was dropped onto the face and then produced the pattern of fractures. So these are individuals that we can't be absolutely sure of the context, but there's probably sacrifice going on here, and this is a pattern that we see in other sorts of contexts in other parts of Peru. And so here's that actual bundle. And another feature of Dragonfly, of course, is using Movie Maker, which is quite important doing public presentations, not unlike this. This particular view is showing you the arms were together on the back of the individual, but there were no hands. So as well as the blow to the forehead, the hands were cut off. And the other thing to realize from that video that went by quite quickly was the individual was buried face down. So most of these people are in a seated flex position, either seated or perhaps sometimes on their sides. But this individual was face down and was extended at least to the knees, and the legs were folded back. So that's what we call a deviant burial. So this individual was killed and then buried in a way that was different from everybody else. And so we're able to reconstruct that again from the CT scans using Dragonfly. And something that we're not sure whether it actually represents violence or not, is what's described as trephination. That's actually drilling a hole into the skull of individuals. Often these are secondary to things like those blows to the occiput of the individual that we just saw, and so they would go in and they would do this trephination and actually pull out the little bits of bone. These ones don't seem to be, so you can see there are actually three holes there. There's one complete hole. I'm not sure if you can see my cursor. And then there's a partial one over on the left, and then down a little lower to the right on the occiput is one that they were just starting, but they gave up on. And so using the ability to cut into the volume of the skull using Dragonfly, what we're able to see is that second trephination that they got partway through but didn't complete, they actually hit a meningeal artery. And so the individual would almost certainly have bled to death from that trephination. So they had started on the third one and probably just gave up at that point. And this seems pretty extreme to us, but it was not at all uncommon in Peru. And in fact, some people actually had multiple of these things. This particular individual has 4 that we can see. The most I've seen is 7, and so they often do survive this, you know, in the example I just gave, the individual did not survive, but a lot of the time they do, and so this is indicating that they're really quite skilled surgeons. Looking at artifacts is quite interesting. So what you see on the right there are some metal artifacts. This thing is a sort of representation of a fish, and then the things on the right are actually different kinds of tweezers. Here what we've done is we published this particular paper in a journal that has a policy that they won't publish images of human remains, but they will allow you to make a drawing. And then I use Dragonfly to segment a number of the artifacts out in 3D, and then we placed the 3D images then onto the drawings. And that actually turns out to be quite an effective way of illustrating in the particular artifacts in this particular case. And the individual on the left is a 6 to 8 year old child. And so at that stage in the development of the skeleton, we can't actually tell if an individual is a male or a female. But those 2 metal things, they're called tupus, which would have been used by women or females to clip a particular garment that women's tended to use. So that's likely to be a female child. And then the individual on the right, those little sort of round things are actually chalk balls that would have been used for to give friction to your fingers when you're spinning or working with textiles. And so other things that we sometimes see in the bundles, and I don't know if anybody wants to venture a guess in the chat what you're looking at there. Some of the things take us quite a while to figure out, but I'll give a sec if anybody wants to take a guess at what they can see there. Well, it's a corn cob. and so they would put food offerings into a number of these bundles, and so that's one of the things that we're trying to understand is which bundles get the corn cobs and which ones don't. This is an interesting slice view of an individual. In the middle of those, there's a stack of these tubes that you're looking at in cross section, and we're not quite sure yet what the tubes are. We believe they may have something to do with textile production. Some of them sometimes have something dense in them that we think is probably a pigment, but we're not sure. I've got one student working on identifying the artifacts that we see in these bundles, so hopefully she'll come up with something for us this year. And then this is a bundle of a child. So the youngest children are actually buried in an extended position. They're not in a seated flex position. And so exactly when that change happens is an interesting research question that we're trying to figure out. But this particular individual, you can see they're buried on a little crib-like thing that in Spanish is called the cama or bed, and so that is part of the whole bundle that again we're able to visualize using Dragonfly. And then finally, identification of textiles. So textiles are a big part of the bundle, and trying to understand how the bundle is constructed is something that we're really interested in trying to do a better job of. And what you can see there clearly is that there are multiple layers of textiles around the head. The head is often wrapped separately from the rest of the bundle. And then there's sort of a neck piece. But really, sort of, the bundles can be very complex, and the textiles they're folded and sort of draped around, and so this is an area that we really are trying to get better. And if anybody out there has done imaging of textiles and has some ideas of how better to do this, I would be all ears. But this is that same bundle windowed and leveled down a little bit. And what's really interesting about this is that the textiles in this case are quite dense. So they're treating the textiles with something. I don't know if it's the pigment that's making it dense, or if there's some sort of plaster maybe that they're putting on, or a resin or something. But that is something that we are still actively trying to figure out. And in fact, using Dragonfly, we've done scans of known objects, and we've been looking at Hounsfield units and things like that. And so that sort of artifact characterization is an area of ongoing research. And so just going back to that analytical workflow, so we start with the scan of the individual, and we go through and we look at, you know, the cranial modification, we look at the mortuary ritual, we look at the artifacts that were in with them, and the ultimate goal is to bring that all back together to recreate that microcosm, right? So who was this individual, and what was their life like, as we can see from all these different features that we can reconstruct on the basis of using Dragonfly to help us analyze the CT scans. And you know, the idea, we're opening the curtains to make seeing the unseen, right? We're using these CT scans to non-destructively see what is inside the bundle. And then really the next objective is what we refer to as knowledge mobilization. So I've cited in this presentation a number of theses and dissertations. So I've had a number of MA theses and PhD dissertations have come out of this. I've done a number of academic publications and presentations, not unlike this webinar. Public presentations. I've done presentations to the public in Lima, so that they're hearing about their prehistory that way. It generates material for classroom teaching, and for our partner museums, they've been using content for their own particular outreach programming. So that's it for the presentation. Just many thanks to, over the years, all the team at ORIS and Dragonfly, who've been incredibly patient with my odd and unusual questions. Thanks to Verena for the invitation to present here. And of course to the team. Jocelyn Williams and Lucia Watson are my co-directors on the team, and I've got a whole legion of students who've been part of the team over the years. Denise and Sarita are at Museo Pachacamac, which is where most of the material has come from that we've been working with. And of course, funding from the Social Sciences and Humanities Research Council of Canada, and New Frontiers for Research Fund with Natalie Resnikoff, who's worked quite closely with the Dragonfly gang. And that's what paid for my fanciest, newest computer. And of course, thanks to all the mummies. And that's it. So I can stop sharing.
Thank you, Andrew, for this very interesting and insightful presentation of your research. It's quite intense what you are doing. The whole workflow contains many steps, but it's amazing to see how Dragonfly is fostering your research and helps you to investigate all the details in the mummies and study all the separate components that are included within the object. So we have one question in the Q&A section to everyone, feel free to hit the Q&A section and put in your questions that you have to Andrew. I will read it to you, and maybe you can answer it. What is the age range of these mummies? You are seeing neonates, infants, juveniles, but how old is the population getting to?
So it's an excellent question. So that's part of the osteobiography. So I showed you the one image of that young child. But yes, we are getting neonates, and we are getting a full age range of what we refer to as non-adults, and the oldest. So it's very difficult, despite what you might see on bones or forensic shows. It's actually very difficult, even when you've got the bones, to come up with a good age for a skeleton, and it's even more difficult to extract that from a CT scan. And so what we do is we generally tend to categorize between young adults, middle adults, and old adults. And so old adults are individuals who've got osteoarthritis, and the sutures of the cranium are fusing, and they've got lots of dental wear, and their spines are getting showing decay and stuff like that. So I would say, if I had to put an age onto it, I would say these people are probably getting into their 50s, maybe some into the 60s, but the most common age range is young and middle adults.
Thanks for the answer. I hope this answers the question for the audience. There is another question. Out of curiosity, what would you say your greatest imaging obstacle with the mummies has been, and how have you overcome it?
So I think probably the biggest obstacle is those damn cotton seeds, and they're very difficult to overcome, and that's in part using the crop shape tool, or the shape crop, because if I'm looking at the skull, using the sphere crop, I'm able to position it right around the skull, or if I'm looking at the pelvis, I usually use the sort of the rectangle, and I can change the angles that I'm looking at, and so I use that to crop out as much of the cotton seeds as I can. Certainly oh yeah, one of the things that I forgot to mention was the the standards, the techniques that we're using on the different scanners in different years being slightly different. That means that the deep learning model that's being trained on one set of scans doesn't actually work very well on the other one. And I mentioned this to Hubert, and he sent me a video which I have not sat through yet, that says, "Oh, here's how you fix that." So so that's on my to-do list. But that's something that we've had to work around. So we have to come up with new models for the different sets of scans.
Yeah, I see. But machine learning in Dragonfly helps with that, right?
Oh, for sure. Yeah, and it also helps to have the new computer that I've got there. It's got 512 gigs of RAM and 24 gigs on the video card. That does the deep learning very nicely.
Yeah, yeah. So you hear it, audience. The system requirements play a role, especially when it comes to the to using our AI tools. But nonetheless, you can use Dragonfly on any laptop, basically. But for better performance, yeah.
Yeah, and for a lot of the basic imaging, for the slice view, and certainly the measurements and slab views and stuff like that, I've been running those on 32 gig and 64 gig computers with no problem.
Yeah. Okay, there is someone studying plant biology asking whether you or your group is doing specific work in seeds that are contained in the bundles.
Okay, so that's a great question, and I was just having a conversation with my student yesterday who's looking at artifacts within the bundles, and one of the things that is really interesting, that it's often included in the bundles, are necklaces made of nectandra seeds, and nectandra seeds are seeds. They're sort of oval, and they've sort of got a natural little hole in them. and they may play a role in hallucinogenics, and there are other sorts of folk medicine uses for nectandra seeds. So that's something that's very interesting. But sure, certainly whenever we see a seed that is obviously not a cottonseed, we try and pull those out and identify. But again, with the resolution of the CT scans, like Pauline trying to identify the remains of the insects, that's right on the level of resolution if they're fairly small seeds to actually see on the clinical CT. That's a good question.
Then to continue also a bit on the textiles and the seeds, there was the question, is there the ability to scan the textiles or seeds separately to analyze their individual densities so you can crop out more accurately?
So at least superficially, that would involve unwrapping the bundle, which is exactly what we don't want to do.
Yeah.
But certainly, I mentioned that we've done scans of, I didn't describe it very well, but we've done scans of these sort of Tupperware things that have different kinds of shells and ceramics and and metals and other things in them. And certainly what we could do is do more of that with known textiles. And so that is something, now that we're really starting to identify this as an interesting area, the student who's doing the artifact stuff she's particularly focused on metals and more obvious things. But I think certainly this season it'd be great to do some better consultation with somebody who knows their textiles. And I've done a little bit of that with an expert from the University of Pennsylvania, and she was able to identify a particular kind of weave. She was getting very excited about it's a particularly complex, I think it was a chain weave or something like that, that she was able to see on the CT image. And so what I really need is somebody who's an expert in Peruvian textiles who can sit down with me and Dragonfly and and become one with the bundles.
So you hear it. The intention also of these webinars, this webinar series, these sessions, is to connect our community and bring them into discussion and maybe collaboration for further projects.
Sure.
Your answer to the last question is also answering somehow the next question, so I would skip that. Here the question was if it would be possible to open the mummy, but you were answering that already.
Okay,
this is exactly what you wouldn't do.
Actually let me address that a little bit.
Okay.
I don't know if you noticed that on the 3D image that I had up of the one bundle, you could actually see some of the bones in the middle of that image. And so often the bundle has these natural openings. And when in that case, what we'll do is we'll grab a little bit of textile from the innermost layers of the bundle, and we'll use that for carbon-14 dating. And if the opening happens to be over the head, we'll take a little sample of hair for isotopic analysis, which allows us to reconstruct diet. But the whole idea is to be non-destructive, or in those particular cases, minimally invasive. We don't create any new openings. We don't unwrap the bundle. The idea is to keep it as its microcosm.
Yeah. And then the next question is, can you please explain which chemicals were used to preserve these mummies? Do you think that with the passage of time, the real characteristics of these specimens maybe change?
Okay, so these in Peru, we generally think of there being three different kinds of mummies. So naturally preserved mummies, anthropogenic mummies, so that's where there's been deliberate intervention, taking the organs out and stuff like that, and then naturally purposefully mummified individuals. Most of these are naturally purposefully mummified. So the wrapping of the individual, the textiles themselves, actually, they wick a lot of the fluids away from the body as it decomposes, and most of the ones that we've been working with have been buried in the sand of the desert coast, and so that promotes the preservation. what they actually did to prepare the individuals, it looks like in some cases that there is something that they're smearing onto the skin. Exactly what that is, we don't know. The Spanish chronicles talk about a tula balsam, which is a particular kind of resin from a tree. But in most cases, the very earliest mummies were anthropogenically mummified, and some Inca mummies, in a particular case, which are late in the Northern Highlands, were anthropogenically mummified. But the vast majority of them were just this sort of human promoted, naturally preserved.
Okay, thank you. So this was the last question. I think we could then finish the session. I would really like to thank you again, Andrew. It's really nice to see how you grew together with Dragonfly and are using it since now more than 10 years. 2013 is a while. That's amazing, and yeah, we love supporting your research, and the software is helping you with your discoveries. I will share once more the QR code to our community platform, Dragonfly Social. Feel free to register, and also you can find me there when you can message me and reach out if you are also interested and not on our screen to give such a talk. Somehow, I hope that you realized this webinar series is some sort of an all-year ongoing conference to, as said, connect scientists of all fields of study, of all research areas, and bring them together and show what Dragonfly is making, Dragonfly 3D world especially, is making possible. Thank you